So what's under the bubble wrap? Well, believe it or not, I've got no church services to do. It's Sunday. And back when there was COVID lockdown, we used to do Sierra Hotel 1 Tango set Sunday. And we used to do mainly the great GT8, 58, 868, or even the 848s. And I've been sent in a Fidelity 1000, so it's a GT848. It's immaculate, I've been told. Now this customer is a very well respected electronics engineer, and he works for a very well known firm in the south. He's a radio ham, and he has a hobby of restoring crystal controlled 2-meter ham radio sets from a bygone era, and that's fantastic. So of course he could sort this out himself, but he knows that I've got a lot of experience on this model, especially if I can find the service manual, which is definitely here somewhere. I'm going to pause the video while I find the service manual. And there we have it. Original had a red front. So this radio, he says it powers up for 1 second and it doesn't. So I'm hoping it's going to be around the voltage regulator. And it's either going to be the Zener, the electrolytic capacitor, or the BD241, is it, transistor? But that's where I'm expecting the problem to be initially. And then hopefully it'll just be a matter of a realignment. And then we can do an on-the-air test. These usually work very well for me. We know there were bleed over boxes at the time, but these days there aren't people every other house with a silver rod aerial. And with me being in the middle of nowhere, that also helps. But we have had some sets so bad, it's lost its label at the back. We've had some sets so bad that they even pick up the radar from 4 miles away at Cranwell. And that was the Signal 1001, which I struggled with because of radar interference. You really don't expect them to be that bad, but there we go. So connected to the test equipment. These should have an extension speaker socket. So hang on a minute. Has somebody put a Fidelity front on a GT858? Now then, is this a Frankenstein? Oh dear. Because that's the difference with the Fidelity 1000. It actually has the extension speaker socket, which the GT858 doesn't have. I think we'll better take the bottom cover off. Well, we're going to end up having the bottom cover off anyway. It'd be hard to believe that somebody would turn a something else into a Fidelity 1000. Or did they just have a bit of a dodgy extension speaker socket and decide to link it out? So if it's a Fidelity 1000, the board will say 848 on it, and if it's not, it'll say 858 on it. Changes glasses, and what do we see? It says 868. There's no sign of it ever having had those fitted. So theoretically, oh, it's had work round a voltage regulator. So theoretically, you would think it was correct. Well, I don't remember seeing it like that ever before. Perhaps my memory's playing tricks. No, it doesn't show extension speaker sockets fitted on this version. It does say 868 on the board, so there we go. Perhaps it's a bit of a oh, this is a bit light. No, there's no extension speaker socket fitted, so where have I got that from? Well, I'll tell you what, there's a Fidelity 1000 propping up the camera which is on the inset. That camera, it sits on the test bench opposite me, and it sits on top of a Fidelity 1000. But unfortunately, I can't see the back of it, and I don't want to move the camera. That really helped, didn't it? Oh well. It's just have to set up with the test gear if you haven't got an extension speaker socket. So one of the downsides on these sets is they're not a 4-watt radio. So at the best, they're a 3.5 watt radio, like most new sets that come out of the box are. You can rarely get more than 3.6 out of current new sets. So it's not really an issue. But they're not a 4-watt radio. So what does the service manual think about that? Yeah, it says it can do 4 watts, well it can't. But in actual fact, it then goes on to say that anything above 2.5 watts is acceptable. Yeah, it says it adjusts for 3.5 watts. You know, so it's a bit of ball, isn't it? Right, I'll switch the power supply on. I've no problems in switching on at 13.8 volts. Of course, we know the set isn't dodgy in that respect. So there we are, 13.8 volts. We're not even powered up to the famous crocodile clips. Try again. Yeah, comes on. It's on channel 24. It's now on channel 20. So that's fine. It's drawing 202 milliamps. And at the moment, it's still on. So I press transmit. And it does nothing. Let's get our monitor receiver on. Testing 1, 2. Testing 1, 2. And it isn't going into transmit. So let's put a signal on the signal generator. We're on 27.79125. Test set's only been on 10 minutes, so we'll take any readings we get with a pinch of salt, but I'm not expecting to get the radio working in 20 minutes anyway. So I'll need to put a crocodile clip lead because of the absence of the extension speaker socket. So I don't know which one is what you'd say hot, or whether we need both. Is that the hot? Okay, so you need to connect negative as well. Now we don't normally have to, because it's going to get its earth return through the test equipment. So the signal generator is on absolute full whack, and it's not receiving anything. So it won't go into transmit, and it won't receive anything. So we'll need to start looking at whether the 8-volt rail's missing, or whatever it is. What a dreadful copy. So around here, so the base, we're looking round that transistor BD241. We've got a Zener diode used in it as its reference source in its voltage regulator. So we should have, I seem to remember it's something like 5.6 volts. Might be totally wrong. And that's what we should have in that area. Diode 11. Expect these are negative earth. Just prove that. Yeah, 13.7 volts. So we have 8 volts on the reference. Let's turn the set over. Can't see the meter then. 8, 13, 8. Well, looks to me like it's generating the 8-volt rail. So in that case, that's as if the synthesizer isn't running. So let's just set off. Put that to there. Might get it the right way round eventually. So a quick check is the 10.24 there, and that's between pins 3 and 4. Just get the oscilloscope out and we'll monitor that. I'll do it between earth don't bother with the oscilloscope probe, we'll just put a screwdriver on it. I just need to know which is pin 1. I can't easily see that for some reason on this chip. So with this way on, so pin 1 is the row by the crystal. Switch the set on. Now we have 10.2385. So I'll tell you what, let's just bring that up. Okay, don't adjust then. How strange. Okay. So we know that that's operating. So chances are the phase-lock loop chip is getting its power and working. Otherwise, it wouldn't be working its internal oscillator to do that with the crystal. It's a long time since I've had to investigate as low down as that in the circuit. Normally on Fidelity 2000s they're very reliable, and you end up with you can have problems around the regulator, you can have problems around this resistor which has been replaced. If you get to the highest WR, that can burn out and the radio will produce half a watt. You know, things like that. And then it's always alignment, but in this case we're just not getting there. So we're going to have to start at the beginning. So they want you to put an oscilloscope to pin 8 of IC201, which is the phase-lock loop chip. So 1, 2, 3, 4, 5, 6, 7, 8. Yep, I can see that. And adjust L201 so that pin 8 is logic high. So 8 is there. I'll just move that pin a little bit. 1, 2, 3, 4, 5, 6, 7, 8. And now we're going to find which is L201. L201 is here. It certainly has changed. I'll just pause the video while I set this up. So a couple of days later, do we do that in a French accent? It's a couple of days later, RS, this is Tuesday, this was started Sunday, RS have delivered some. So I took the two out. Shall I test these or shan't I test them? It doesn't matter whether these work or not. We're not putting them back. And although tantalum bead capacitors are very reliable, more so than electrolytics, they can fail. And that's one that's failed. And that one hasn't. At the same time, we're going to change to 220 microfarad capacitor. So it might burst into life after this, because it's a matter of changing the cheap components. The phase-lock loop chip, very, very reliable. I have had one, I think I've changed one in 40 years. That chip can fail, but you see, with this having had the regulator replaced, we don't know that this hasn't at some point passed full rail voltage to this section instead of 6 volts, whatever it does. Right, so we'll put two of these in, and we'll put a new electrolytic in that section. I don't recall ever having had any of these fail on one of these sets. I'll pause the video and get on with it. So we've changed the phase-lock loop chip, which for one I recovered off a scrap chassis, and I haven't got, I think it's the only scrap chassis I've got, and that's now brought the set into operation. So of course, whether the phase-lock loop was killed by that Duff capacitor or whether it was killed by an over voltage is another matter. So there we go. So theoretically an expensive part, I think they're about £15 if you can get them. So we've now got the meter on pin 8 of the phase-lock loop chip, and we've adjusted CT202 so we have a logic high. So if I adjust it, you've got logic low, which is 3.5 volts, readjust it, and this is on channel 20. So we do the same on transmit. So it's logic high, and this time it's L201, the second one from the left. So I'll just do that in front of you. Without trying to short out the next pin. So we've got no transmit. And there we have, actually on the frequency counter, 7912, whatever it was. It was pretty close. So now we can just tune up the transmitter in a normal way. I'll just turn the volume down. So it's interesting that the squelch was active, there was no background noise on receive. If I turn the signal generator off, we've now got the FM hiss. We didn't have that before. Now I did change a couple of capacitors in this audio department, barking up the wrong tree, one of which wasn't 100%. But the whole squelch thing isn't active until the phase-lock loop works. So the receive is inhibited as well as transmit, which is quite unusual. So if we just go through the normal lineup, I'll put picture in picture on. There we go. So we're on the 3-watt scale. That switch wants a bit of a clean. And the radio is doing 2 watts. So it's not actually even faulty. This is building up slowly, so this is a temporary measure. If I've got another crocodile clip lead, if I want to link out the high-low power switch, unless we can quickly spray that. I don't have an applicator here. So it's about 2.2 watts. And now we need the hexagonal kit out. Now, I don't know whether that end one's supposed to have a core in it, because I can't remember. So if I look at my one and only scrap chassis, it is slightly different. See, we've got the, we've got the do not ever adjust one for the second harmonic there. I'm going to have to look at some photos, because we've got, that's a GT868. It's nearly 2.5 watts. I wonder if there's any transmitted audio on it. Wallow, 1212. Not that I can see. Wallow, yeah, there is. Excellent. Just have a monitor receiver on and see what we can hear. One two testing 1 2 1 2 1 2 1 2 wallow. So there's still some fine tuning to do. It's taking about 3 seconds to go into transmit. It's a bit like a New Midland. They do that. As Mr. Chippy knows. And just for a reference, we'll just see what we're actually receiving at. I'll put the synad meter on and I'll show you that, because it's less likely that this has been fiddled with. It's right now it's doing 0.6 of a microvolt for 12 decibel synad. So I mean that's 0.3 we can hear, so it's receiving very with good sensitivity. So I'm going to take a lunch break, and I'm actually looking forward to doing a scratchy corner test with this one, because I do like them. It seems that I like anything else that nobody else likes. You know, it's the puppy with 3 ears and 2 eyes, and no, that wouldn't be right, would it? The puppy with 1 eye and 3 ears that I would want to fall in love with. You know, it's all that kind of thing. Good. Well, we're going to leave it on, and then everything's going to come up to proper temperature. I just thought I'd better put the spectrum analyzer on this radio, with it being, you know, a bit of the unknown. There we go. So we've got this the second harmonic, 54. What is it? 55. I got the wrong glass on. 55 point something. So it's minus 67 dB. So we'll just. I've actually got a tiny bit more power, like 0.1 of a watt out of it, and we're still at 67, minus 67. So that's good. I've stabilised all this, and if we go back to the power meter and I key up, it's instant. Key up, instant. So it's just a matter of some of these other coils, which I don't know the true purpose of, but we've just peaked them for maximum lock. So I think we'll just go through this once again. Just over 2.5 watts when warm, which is I think a good result. So remember, this is a 3.5 watt set. Don't be fobbed off into thinking it's a 4 watt set, because it isn't. I'll just try that hex one once again. Definitely peak. So let's do the deviation. It was a bit high before, so just drop it a bit. Just try it about there. Oh, I'm in the wrong. Wallow. That's interesting. According to that, I'm transmitting a noise. One, two, 1, 2. It's not the spectrum analyzer, is it? Turn that off. Wallow. I'll just look into that. I've just realised we've not got the screen plate on underneath, so that's probably what's generating the noise. So I've cleaned it up with isopropyl alcohol where I've done the component changes, and we'll pop that screen plate back on. Right, that's the screen plate put on, and I've put the bottom on as well, so we can just make sure the tuning's spot on. It's got rid of that noise. Wallow. So we can set the deviation, which was a bit difficult when there was 1.5 kilohertz of hum or something. See where that is. Whoa, whoa, miles over. Let's try it there. Wow, that's the bit over, 3 and a bit. Wallow. Wallow. That's about where we should be. Testing 1, 2. Let's put the monitor receiver on and make sure it actually sounds like something. Testing 1, 2, 3, 4, 5, 5, 4, 3, 2, 1. I will check it with the customer's mic. Now, shall we do that now? Then we'll carry on doing the rest of the set with my mic. Testing 1, 2, wallow, 1, 2, 1, 2. Yeah, it's still the same deviation. Right. We still need to investigate that coil, don't we? But we'll just do the transmit frequency. The test set's been on for about 4 hours, so I don't think it's going to be far out. Press transmit. I'm going to put it on frequency as we said. So 2779132. I set it up originally with the little oscilloscope on the 10.24 here. Have it very slightly high. There we are, 2779126. Now doing 2.5 watts. And I said I still need to look into that. So we've done the deviation. For the laugh, we'll do the meter. So we've got one of these is squelch, and then there's, oh, that's going to be meter. It's going to be RF meter. And although we may not be yet at full whack where we're going to be, let's just see where what this meter's saying. It's banging across. And it should be in the centre of the red zone, regardless of how many watts it's really doing. So, that brings us to receive. See if we're on frequency with the signal generator. We are. Oh, that's neatened it up a bit. So all we need to do is to put a connection between our test equipment's loudspeaker input and whichever one's hot. That's hot. That's not hot, so it's that one. No, it does need both. Well, surprise, surprise. Normally they pick up their through the aerial or whatever. There we go. So using the cyanide meter, so basically we're going to go through, well, we've got this T4 and 5 which they do with a sweep generator, and we don't. I've shown you that before, but we've started doing 4 and 5 with the cyanide meter instead. We'll do those later because it's a funny type of detector arrangement on these sets. It doesn't have a clever FM chip like most. So we're looking at L1, 2, 3, T1, T2. So L1, 2, 3, T1, T2. It doesn't mention T3, but we've got T3, so there we are. So we'll start with start this way. I got this the wrong way around. L1, L2, L3, T1, T2, T3. That was already spot on. That was already spot on. That was already spot on. Change tools. That's the first one that's needed adjusting. And now we've got these fun ones to do. I'm going to put the oscilloscope on as well. So we're trying to get symmetry on this. Oops, wrong one. Just take the bench light off. So we're trying to get best symmetry and maximum output and best synode all at the same time. So you can see we've got a definite peak there. So that one's right. Go back to synode meter. That appears to be where we should be. So have we actually done any better? It was 0.6 of a microvolt before. It's 0.58 of a microvolt now. So you could, yeah, it's better, isn't it? But this threat hasn't come in because the receiver's out. It's come in because it stopped working. And that's been in the phase lock loop department. Right, we'll put an S9 signal on the radio, an S9 equivalent signal, and let's look at the S meter, which should be reading, if we don't short out the power lead as usual. Should be reading S9, and it's kind of plus 30 plus plus. So it should be there, and it is now. And then finally we've got the squelch, and the squelch is weird on these. It's an AM squelch detector. So we're going to set the squelch to full. and I would like it to come in when we hit S9. So that's 100 microvolts. So 1 microvolt, 3 microvolts, 30 microvolts, 100 microvolts, exactly where I want it. It's the adjustment there, had it not been spot on. So don't need to touch it. It is spot on. Well, I'll go to the foot of our stairs if we've had any. So now do the opposite. We're going to switch the signal generator to standby, set the squelch to threshold, switch the signal generator back on, and see when it comes in. Wow. Well, it comes in at 45.45 of a microvolt, and it disappears off about 0.3 of a microvolt. And this is these sets on doings. They're very sensitive, and of course back in the day when everybody had a silver rod on the terrace house, every other house, these were of course a big bleed over box. But these days I don't find them to be a problem. I remember Mark coming to stay once. Oh, we've got a interesting. We've got a capacitor off there. So Mark came to stay. That's ZX2 who labels some of the sets, and he had urgent need to contact me, and he knew I was somewhere around in town. He knew I was about finishing my work there, and there was no CB set up here. So he pulled a Fidelity 1000 off the shelf and called me, and we made contact because he knew that it was going to work because they're very reliable. But what's happened here, I don't know which one it was, but one of these two capacitors failed and they went short circuit. So the 0.47, where are they? Here. Got those two there. Well, whatever with one of those going short circuit, it's killed the phase lock loop chip. So there we are. But I was able to recover it off that scrap set. I dread to think how much they are. It's an MM55108N. MM55108N. I didn't even bother looking if we got them in stock because I know they'll be horrendously expensive. And with him being another electronics engineer, I'm trying to, be really, really good with him price-wise. So I need that to look at that, and I need to just look at a photo of another set to see whether that should have a core in it. I'm quite satisfied at 2.5 watts. These can do anything from 1.7 upwards. If they're less than about 2 watts, though, this resistor can play up. But yeah, I mean that's absolutely fine. So I'm going to go and look at some photos and just make sure that that is supposed to be soldered to there, and then I'll come back and finish off the video. So it seems there's several versions, doesn't it? I mean, I've never seen one without an extension speaker socket before, but it's clearly never had one. And then sometimes you've got an air-spaced one there. We've got the air-spaced one there. I look at photos and they do differ. So I don't think there's anything missing, and it's doing the power it's supposed to be doing, which is 2.5 watts. As I said before, if that resistor starts to fail, then it goes down, but it's not gone down to anything silly. And remember, when my power meter is 2.5 watts, it's probably 3.5 good buddy watts. So there we are, we're done. And what we'll do, we'll put the lids on, we'll solder that speaker back on. Just turn it off for now. I've sprayed the volume control because it was a bit iffy. So red is the hot lead. You might expect that, but not always. And it's the right hand terminal of the speaker. It doesn't matter on a mono system, which this is. I've also put the VCO cover back on. I put a bit of solder there because you can end up with microphony. That's when you tap the radio and it transmits that tapping. So just put some fresh solder on there. So I say normally these are very reliable, even if they're well known to be poor performers as well as the receive goes, but that was only the case back in the day. And a bit quieter on receive, as in, because I don't have a clever FM chip, when you actually switch it on with no input, and I'll turn the signal generator off. I won't yet. I'm going to put the screws in. I was going to say the actual FM hisses quieter on these, so they're better on the ears. Have you got your ears on, good budgie? So although this set's not immaculate, considering it's 40 years old, it's in very good condition. But of course when it last worked is another question, isn't it, with a fault like that. Right, so we'll connect it to our aerial in a moment. Just do one final check that it's on frequency and transmitting without any hesitation. 2.5 watts, check. One on a Roger. $19 a Roger. Well, there's nothing unusual there. So we'll do an on-the-air test later on, and that's it. Bit of a swine of a job in the VCO of a Fidelity CB1000 from 1981, when they were £69.99. Thanks for watching.